Warning. Morning, Karen. Morning, Arnav. Hello, Soterio. So if you haven't already, get this one printed out. Arvid. Maha. Thomas. Kira. Nusha. Kalani. Aaron. Julia. Aditya. James. So we'll start in about 1 minute. Oh, John. Hi, Jack. Looks like, Jack, you had no problem typing today. Or Rohel. But Rohel had problem typing. All right. Let's get ready to start. Alright. So today we are going to be talking about segment relationships. So the other day we talked about, last week we talked about angle relation. That has to do with like these angles or something like that. So today we're going to talk about segment relationships. So segment relationships really comes down to the length, okay? The length of the segment. So today we're going to talk about explore segment relationships in circles. Now here, there's same thing as the angle relationship. You have three parts. The first part is inside, and then obviously there's outside, and obviously there's tangent. So it's same thing as the angle relationship, but instead of talking about the angle itself, we are talking about the side length. Okay, so if you look at these three pictures, it almost look exactly like the picture we talked about before in 10.5, but here it's 10.6. What are we looking for? Well, before in 10.5 we're looking at angle, how angle is related to these arcs, correct? These angles relate to these arcs. Now today, instead of doing that, we are looking at segment relations. So if you look at, I'm going to move it down a little bit here, right here. So I'm going to be looking at the relation between these side length, not measures, okay? Not measure angle, it's length, okay? So let's take a look at the following, okay? So let me make two lines and connect. Okay, so I'm gonna connect here and here. Okay, can you tell me how are these two triangles related? How are these two triangles related? Okay, take a look. How are these two triangles related? They are similar, says Jay. How come they are similar? Okay, Thomas mentioned something very important called inscribed angles. That's part of the key reason on how you can prove that these are similar triangles. So can you tell me why they need to be similar? Okay, take a look at this. So to prove that these two things are similar, let's first look at these two angles. How are these two angles related? These two vertical angles. Alternate interior angles here does not work because alternate interior angles requires parallel lines. But in this case, the lines are not parallel, right? Or not necessarily parallel, so you can't use alternate interior angles theorem. But it has something to do with what Thomas said earlier about inscribed angles. Take a look. Which two angles must be congruent other than the vertical angles? Because these are vertical angles, right? These two. So what other angles must be congruent? Okay, let me angle A and C, which is here. This one and this one. Why is that? Well, if you think about it, if you use arc BD like people said, this arc is inscribed by this angle and this angle. Since they're inscribing the same arc, both of these angles are half the measure of this arc, which is the same for both, right? So since they are the same measure, they are the same angle measure, they're congruent. So these two are congruent, these two are congruent, so we call these AA similarity. Now, if they are similar, then we can use proportions to get their side length. So, okay, let's look at this. So that means this and this versus, sorry, wrong one. This, let me call this A. I'm using the wrong color. I'm gonna call this, Alright, sorry, let me change colors real quick. This one, let's call it B. And so, and then this one, call C. And this one, I'm gonna call it D. Okay. So when we do that, because the similarity, we can say A over C is equal to B over D, D over B, D over B, D over B. Okay. So if that's the case, then when you cross multiply, you can get AB equals DC. Well, which one's A, which one's B, which one's D? So it'll be A. EB was A, right? A, and then AE was B. AE, yeah, A was this one, right? AE is B. And then CE was D. C. So basically, since they're in proportion, there's this relationship that we can show, which is the same as this one. Okay? Now, ideally, similarly, we're going to look at the other two. Okay? So how do we remember this? Okay? So next one, I'm going to finish talking about all the theorem first. Then we're going to talk about how to remember them. Okay? So next one, similarly, I'm not going to prove the rest of it. Okay? They're all similar proofs, but they draw different lines. Okay? You all use similar triangles. So the next one is this, okay, times this is equal to this times this, okay? That's the second one. The third one is very similar. This times this is equal to this times itself. Okay? Okay, so let's look at these circles to see how you remember them. Okay. Okay, so every single situation there will be an intersection point, right? If the intersection is inside, then that's right here, right? This is the inside, this is outside, right? Or outside with 2 secant. And this is a tangent line situation. But the intersection is still outside. Okay? So there are several different situations with your intersection, right? So if you look at this, then you can see that the relation goes like this. So from the intersection point, okay? You really want to start with the intersection point, okay? You want to start with any line, okay? And you're going to go this times this, okay? This times this equals to this times this. Okay. So do a line, have a point, start with the point, this times this equals this times that. Okay. Similarly, this is the intersection point. You want to start from here. Okay? So this times this equals this times this. Goes to the intersection each part of the circle. You see? 1, 2, 1, 2. Not this to this equals this to this. It's this times this equals this times this. Okay? Multiplication. Let me put it here. A, B, C, D. So AB equals CD. AB. Oh, sorry. Time out. I did it wrong here. It's A, the whole thing is B. My mistake. Sorry. I always have to start from this. So always has to start from the intersection point. Okay, forgive my mistakes. It's A times B. Okay, B is here. Whole thing here is B, and then C times D is the whole thing. Okay. Always have to go to the circle. So none of this. Okay, this is not it. So this to this, this to this. Okay. All right. This one. Same thing. A. Intersections here to the circle. Intersection here to the circle. Intersection here to the circle. Intersection here to the circle. D is the same as C. So we have AB equals CC, which is C squared. All right. All right, let's look at examples. Look at examples. So, first example is over here. Find the unknown length of the segment. So, unknown length of segment is here. X, right? JH. So, you have to find the intersection, right? Intersection is right here, J, right? So, we're gonna do start from here, and then we're gonna go towards the circle. Okay, so JG times JH. Okay, so it'll be 14 times X. And then once again, is equal to 7 times 10. Okay. because you're looking at the other ones with j, 7 times 10, like that. Then you solve it, right? So x, so 14x equals 70, x is 5. Okay? So take a look at the right side. You can try this one. So this one, start with E. Start with any line. So this times this, right? 8 times x is equal to, the other side is 5 times 6, right? That. So 8x is 30. So x is 30 divided by 8 seems to be 3.75. People already got the answer. How are we doing? Too fast, too slow, just fine. Seems to be understandable for now. So remember, when it's inside, we go find segment. Here times here equals that times that. Okay. You always want to find the intersection first. And this is extremely important when we do outside situations. Okay? So where is the intersection on this one? Line intersection. Which point would that be? Six. You mean the answer is 6? Or E, right? E. Thank you. So here is the intersection, okay? So this setup, this is a very commonly made mistake, okay? So make sure you understand how you set this up, okay? So, first of all, we are looking for here to here, intersection to circle, right? Intersection to circle, that's the first length. The second one is intersection to circle, which is the whole length. How long is this whole length? So 7 is here, but the whole length will be 7 plus 9. That would be 16, right? Good with that? Then we're going to look at this one. 8 is the first part. What's the whole thing here? How long? Is it just x? From here to here. X plus 8. Right. Very nice. All right. Since that's the case, then let us set it up then. So I got 7 times 16. Okay, 7 times 16. Equals x plus 8 times 8, right? So 8 times x plus 8. 8 times x plus 8. Okay? And then use multiply out. 7 times 16 would be 112 equals 8x plus 64. Right, so subtract it over. So 48 equals 8x. X is 6. Okay. Let's do one more together on the bottom part. The last situation, and I'll let you guys practice with the right one if you haven't already, okay? So the bottom one is a tangent situation, right? How do I know it's tangent? Because it only has one length here, right? Because there's only one intersection. Normally you have two intersections, right? So we look at this. So is this is the intersection, okay? So this times this whole thing, which is 20, right? 15 times 5. This is x times x, okay? So 5 times 20 equals x times x. Okay, you can put x squared if you want, but that's how I remember it, so I remember to do it twice. 100 equals to x squared. X is 10. Very nice. Okay. So on the right side, why don't you take a look and try these two problems, and then we'll go over in the end. Okay. So to the right side real quick. And while you do that, let me take attendance real quick. I know most of you are here, but just for the formality of it, let's take attendance. So if you're here, type here. Okay. The problem's on the right, isn't it? Right over here. Is that fine, John? Still missing a few people. Amber, are you here? Okay. Cameron? Are you around, Cameron? No Cameron today? Cameron, if you're watching, come comment later. Sonia? Sonia, if you're around, comment later, okay, if you haven't gotten here yet. I think that's it. Yeah, the rest of you are here. Amber, if you're here, comment later as well, right? Alright, so Cameron, Sonia, Amber, if you are still not here, check in with me later after you watch the video, okay? Right, so these two problems, right? So these two problems, we are going to do this times this equals this times that, right? You gotta look at the intersection. So it'll be 9 times 30, no, 9 times 39, the whole thing is 39. 9 times 39 is equal to 13 times 13 plus z. A little bit. Wait. So, multiplying it out. So you could distribute first, but an alternative way to do this by hand is if you can cancel this out, right? 39 goes to 13 3 times. So then 27 is equal to 13 plus z, right? Because you cancel that out. So then 9 times 3 is 27, right? So z is 14. Okay. Last one. This times this is equal to this times this, right? So 7 plus y, right? So 7 times 7 plus y is equal to 10 times 10, which is 10 squared. So 49 plus 7y is equal to 100. Subtract 49 over. So y turns out to be 7.29. Okay. Divided over, or 286. Okay. All right. Any questions on these concepts? Okay. So, if you haven't already, go on go to find your email, and in there you should be able to find where Sonia is here, but it's not letting her leave a comment. Okay. Can you have her email me real quick? Email me and send the comments here first. Okay. Amber, I also got your email. Oh, Sonia. Magically showing up. So I'm just missing Cameron. Cameron, if you're around, you can send me an email or you can leave the comment later. Okay? Good. So if you haven't already, go find the email that I asked you to go sign up from Big Ideas. The one in the example I used, the code is actually your class's code, period 4. So you can use your thing to use the code to log in there. For other periods though, you have to go for the periods that the individual email I send you, and inside there's a code. Okay. Once you get in there, you should be able to see the assignments now. If not, let me know. But because every time somebody adds, then I have to add them to the assignment. So make sure you do that soon so you can do the homework. Okay. Right now I have 18 people in this assignment. So let me see if I can get people to oh, okay, more join. That's good. So I have 21 people in this assignment now. So we still have a few people to go. If you have problems with this, let me know. But please finish and submit by make sure you click submit, okay? Right now I have one person who already submitted, but if you have done it, make sure you click submit, okay? And this is due this Friday, which is like in 2 days, I guess. So, yeah. Okay. That's it then. And yeah, if you have like questions about individual problems you want me to do, make sure you email me, and then I can go over in office hour, or I can just email you back. Okay? Or you hit me on Remind, that's fine too. Any other questions? Yes. So you don't even have to turn in the pictures this week, because I'm trying out not to let you submit a bunch of photos, because a lot of people have problems submitting multiple photos, and they have to email me. If they have to email me, then I have to check individually, and it becomes really hard to check. Okay? So the only homework this week is to finish the one on Big Ideas. And once you get that done, then you're done. Okay? Class link. My week has been great. Okay. Go to your loop mail right now. Jay and Jack. Go to your loop mail. On the loop mail, there is a link. No, not link. On the loop mail, there is a part that says changes to geometry. Just go on bigideasmath.com. Okay, bigideasmath.com. And then you log in, or you sign up first using the code I send you. And every time you go log in, they will take you automatically there. Okay. It's because Big Idea is only for math. So when you log in, it should take you to where your class is. Yeah, assignment section on top. Thank you, John. Yeah. Oh, hi, Cameron. I got you. All right. Any other questions? No, you don't need to turn in your notes today. Okay? Is that okay? Nothing in assignments? Well, if you just sign up now, there's nothing. Because I need to add you to the assignment. But, let me see. Did you just join? Okay. I see Rahel, Cameron, Jay, and Jack as well. So now I'm going to add you here. Now you should be able to see it once you refresh the page. You have it? I just added you. Got it? Good. So same thing with Rahel and Jay. Okay, I just got you in. So right now I have 25 people in there, which is, I think, the right number of people. Yeah, because the TAs aren't doing it. Right. So it should be, let me see. Yeah, it's just, I think I'm still missing one person that's not in here. Wait, why is Mira in here? Weird. The code is in the email. For this class, let me see. Let me pull it up. Let me type it in the chat. Okay, so in here, if you are trying to add right now, this is the code for this class. Thanks, Juliana. Any other questions before we go? Are you going in okay? Okay. So you emailed last week's picture, but it keeps saying delivery incomplete. So like you tried to send it and it doesn't send? Do you try send it on different? Do you try loop mail? Or you try email? Jay, you don't need to turn this one. How else can you send it? It's a good question. I don't know how to deal. You did it on Gmail? Interesting. Aditya, just hold on to 10.6 notes. Hold on to it. We'll figure out how to turn it later because right now I don't want to deal with individual pictures too much. But for last week's stuff, if you haven't turned it, you should turn it. Sonia, I think what you can try is to go to. Do you have an iPhone? If you're on an iPhone, then you go to the part where you took the picture, and don't you just like click on all of them first, select, right? And then you can share it with me, like through anything. You can even send it on Remind if you can try to send it on Remind. I think Remind is still okay. Try send it on Remind. Do you have Remind? Does it work, Sonia? All right, Annie and Kira, I just got you guys in here. Don't reply to the one that says no reply because that's from school loop mail. The one that's no reply, it won't send to me. You want to send to my actual email, or you have to go through from loop mail and then do attach from there. You can't just do Gmail and then reply to the one that is no reply because that's from loop mail. Brooke, I think you're fine. Let me see your let me take a look at your request, Brooke. Yeah. All right, Brooke, I just sent it over. Sonia, did you get it work yet? Is it already sent? I haven't gotten any yet. Got it. I got it, Sonia. Congratulations. Okay. All right. So, anything else before we go? If you later on join, but you can't, but you don't see the assignment, let me know. I can add you, because if you just newly added, then it won't show up on your assignment. Okay. All right. Goodbye then. See you guys sometime. Let me know. Hit me up on email or remind if you need any help. Okay. Oh, what? I have not yet checked out Hunt Showdown, John. Goodbye.